Device. Test, test. All right, I do have audio now. And I have noise suppression turned on. So hopefully you all can see me here. Just let me know, and then I'll start explaining what I have going on. Okay, audio, visual, good. All right. Good. All right. Yeah, I did have I did have audio at disabled for a little bit there, and so I realized I was talking to myself. All right, good, good, good. This is a little bit outside of what I normally do. So
Good evening, folks, and a hearty welcome to our drive-in theater.
I am completely out of sorts here. One moment. Okay, you can still hear me. Good. Make sure the noise filter is on. And all right, so I am going to switch back over to the camera. I'm forgetting one thing still. I'll be back. Okay, sorry about that, and thanks for your patience here as I'm getting set up. I made the circuit board. I've never made a circuit board before, and it's been a long time since I've soldered anything. Let's see. I have such a delay on the camera. Come on, autofocus, do your job. It really does not want to focus on that. There it goes. All right. In university, if you were like me, you might have had to have done, if you did a computer science or computer engineering degree, well, we called it a 4-bit ALU. We had to design a 4-bit processor, and it had to be able to support a certain set of operations. Yes, there's a link in the video description as to what happened to Reiner. Reiner is diagnosed with ALS, so I thought I would try to do something, and in Reiner's honor, raising some money for the one of the ALS therapy foundations that gets good reviews. So yes, that is part of the point of this. Half of the point of this is that I needed to work on this project. The other half of the point is that I wanted to see if I could do something to help Reiner out. I won't be helping him directly, but help with ALS research. So we had to implement something that could do these 8 operations, and this is the resulting set of operations that mine can perform. So I've got a dip switch for 4-bit input, and I've got a dip switch for the opcode that's being executed. ALS is also known as Lou Gehrig's disease. I forget what the actual 3 letters start with, what they are, but it's a neurological degenerative condition where you slowly lose control of your muscles. It's the same condition that Stephen Hawking had. He is the person who lived with it longer than anyone else in the world. So I had this project from university. This was the resulting schematic for it, which I don't know how visible it is, but we can go back to the KiCad version that I had up a moment ago. Make sure all this is full screened and visible. And these are the resulting operations that mine can perform. And you can see that I did this, if you can read these numbers at all, in 1998, which was quite some time ago now. So this is my circuit board. I ended up designing the thing. In KiCad, and then I had it actually printed with PCB, which I know PCB sponsors lots of YouTube channels. They are not a sponsor of my YouTube channel. I just knew about them because of all the other YouTube channels that they had sponsored. So I directly translated my school project from 1998 into this PCB. And what I've got here at the bottom of the board are my 2 switch packs. So the one on the left is the opcode that is being input. The one on the right is the input value for the actual 4-bit input into the device. And then it's made up of 7400 series logic circuits. And if you noticed when I was actually showing the PCB, I did a terrible job of actually labeling the components on the device. So that's not going to work. My goal at the moment is to try and first make sure that I didn't short anything. And I'll show you why I'm concerned about that in a second. And then the second is to start assembling some of the resistors and the 2 sets of resistor packs, the LEDs, and the input switches. And then I'm going to see if I can get a proper display of the current switch values on the LEDs, because the input bits are supposed to be displayed over here on the right. The input dip switches are down here on the right. Yeah. Okay, so I'm going to switch back over to the camera, and I see the comment that the first thing that you do is check for shorted power lines. And I have a very specific reason for wanting to check that, and it's because of this, which I'm guessing is just barely visible at all on my camera that's not really designed for this kind of use. And this is where I was supposed to have put 2 jumper pins so that I could then easily wire in power into the thing. But they are so close together that I think they might actually be touching. And if they're touching, I think the safest thing for me to do is to literally drill a hole right here to break those connections. And then I'm going to have to wire in on the to the positive and negative pins that we can see wired on either side of this resistor, and on the top left of this, well, what would be the pin 1, I believe, of switch 1. Oh, and also I have a whole stack of these things. So I don't know, if someone wants a souvenir at the next conference, let me know and I'll give you one. And I have a bunch of messages on my phone, so one moment, I'll have to check those. All right, sorry about that. I've actually been planning for a while to do this, but thanks Bjorn. And I'm glad to see on the message that it actually did correctly go to the ALS Therapy Development Institute. It's the first time I've ever tried to set up something like this. So I've got my multimeter currently set in resistance mode, and I'm just going to do a check across these two pins and see if they are... Okay, that's showing that I do not have a short across those two pins that I was afraid that I had a short with. So yay, first problem solved. Let's go ahead and look at the pinouts on these things and make sure that I'm doing anything reasonable here. One second. All right, so the pin out for the 74 153. Let's look at the 74 LS 153 pin out. Sorry, I'm being distracted here for a second. All right, so let's see if I have up the proper thing. Okay, I do. So what I should expect on all these 7400 chips is the pin, the top right pin, if you will, the first of the second set of legs should be VCC, and the bottom of the first set of legs should be ground. So switch back over to camera. So what I'm expecting is that all of these pins across my 7400s should be connected. Uh-oh. All right. Okay, so that was true for all except for the top one. I'm expecting these to be grounds, and these are all connected together. And I'm not seeing any shorts between my ground and power rails. So that's good, but I need to see what that top chip is and see why it didn't get power. Well, I can in fact see that there is no power connected to this pin on this chip. And there should be, what is that one? That's the 74LS2, what? 283. That's my 4-bit adder, and it doesn't seem that it has power. Does it have ground? It does have ground. How did power not get wired to it? I mean, it's very clear that there is no power to this pin. Every other pin appears correctly connected on it. No, that one does not seem connected to anything. I think that's the carry out pin that's not connected as well. Oh no, wait, that is connected. No, this one. I think that's the carry out pin, which isn't connected, which makes sense for this particular application. But I didn't get power to it, so we're not going to get any adding without power. I need to be making a to-do list of what is broken here. All right, I'm going to go get some paper. So my mom just let me know that she's apparently watching this stream, or at least saw the stream went live, that my grandfather's father died from ALS at the age of 62, which I think I might have known, but it's been a long time since I thought about that. All right. So the adder doesn't have power. And my pin jumpers are far too close together. Or power pins are too close together. Um, Otherwise, it seems like it might be safe to maybe start assembling some stuff on here. Because there's no obvious power ground kind of shorts that I can see. Shouldn't be anything across any of these pins. None of these things. Those are all my LEDs. These are the resistors to protect the LEDs. And these are the pull-down resistors for the inputs from the switches before they go to the rest of the logic circuits. So I guess I'm going to turn on my soldering iron for the first time in an extraordinarily long time. Did I run ERC and DR? Did you catch the title of this? I say amateur assembles and tests his first PCB. I have no idea what ERC and DRC means, and I barely only know what a Gerber file is. Basically, in KiCad here, I clicked the button that said send to PCBWay, and they did, and then I got a circuit board back. This is the logical version of the schematic. Oh, look, I didn't connect it to 5 volts. It's right there. Ah, oh, goodness. Why don't you just go ahead and do. Hey, look, I fixed it. It'll be better in the next version. Oh, right, sorry. I'm not showing the screen. All right, I'm going to make sure I'm sharing the right screen and go, all right. So this is my KiCad setup. And what I just did was I fixed this missing 5-volt connection on the adder. Yes, in ohm mode, I don't think I have a continuity tester directly on this particular cheap multimeter. But in ohm mode, I can say that there is infinite resistance or no resistance, basically. So that's basically what I was doing to check continuity. All right. So run ERC and DRC before KiCad has electrical rules check and design rules check. Electrical rules check. Electrical rules check. And design rules check. ERC, DRC. I have no idea what I'm looking for, so if you can tell me what. Repair board. It's under inspect. Inspect. Design rules checker. Run DRC. Warning, silkscreen overlap. Hey, look. Warning, clearance violation for those 2 pads. I should have probably run that sooner. Oh, that's the only warning it gave me. It didn't give me anything. Ooh, unconnected items. Can you... Wait, is that... It doesn't see any unconnected items. There's clearly still an unconnected pin on the PCB layout. I know there is, because I didn't rerun the PCB layout. Footprint component type doesn't match footprint pads. Unconnected items. Show all. No, it still isn't showing me unconnected items. That's not very useful. And I think that should be called run DMC, just for the record. Okay. Yeah. All right. My soldering iron is on and hot. And I don't have any flux because I didn't buy any. Reiner has ALS. Excuse me. He announced it officially on his website. You can see a link to the blog posting in this video description. Oh, I'm sorry. Oh, I have to do tools update PCB from. Yes, I know that. Wait, tools update PCB. Yeah. Okay, so yeah, it's connecting that now because I already did it in the schematic in the not the schematic yes, the schematic layout. Excuse me. I have to rerun routing to actually get it to do that connection too, I think. Yeah, it's showing the wire right now, but doesn't actually have the routing. As long as this is still up, I'll show you all how I did this. I let the I let free routing do the hard work for me. Now I do have. Well, whatever, bother. I'm not going to bother with that right now. Okay. Yeah, I don't know. I've got cheap solder and no flux, and I have no idea what I'm doing, which is part of the point of this video, I guess. All right. So I need to get some good solder with good flux. What I had, so for those of you who are, commenting about types of solder with flux or not, let's get the camera back on. What I had was some really, really old high lead solder from my grandpa from so long ago. And then at some point I got some of this silver bearing solder, which has worked for the few things that I've needed to use it for, repairs and such. And that light is just way too harsh. No, that didn't change anything. That's still blown out. Is it actually better with no direct light on the scene? Might be. All right, indirect light it is. Although it makes it slightly harder for me to see what's going on. So I have my little dip switch blocks, and I got sockets for all of these so that I can blow up chips and then replace them. But I did not for my dip switches. So I don't know. I found like it was shockingly hard to pick a set of dip switches that I wanted. But I'm going to install them like this. And we're going to start actually doing something and see what happens here. Sorry, I'm off camera. I'm not used to doing this kind of camera thing here. All right. So I let the pins stay kind of flared out as I snapped it in there. So it's kind of holding itself in place. And I'm glad to see that the footprint and everything is correct. And I have just very little concern about the dip switches in general. I'm much more concerned that I have right size resistors that'll fit here for the pull down resistors. But I'm going to do both of these set of dip switches at once. All right. You have a feeling like your eyes are too old. I need a pair of those. Yeah, I was thinking about the resistors. If I have to, I'll have them sticking out or I'll mount them vertically or something like that. These ones, I'm almost positive I have enough room for. These, I don't know how they ended up with a smaller footprint. All right. Let's see if I can do something kind of reasonable here for lighting. Yeah, the pins look good. I'm going to see what they look like on the camera. I might try to actually, if I'm soldering, I may as well make the camera a little bit closer, huh? Focus, camera. Why won't it focus on the thing that's primarily in view? That is so weird. I don't know what to do about the focus. Hold on. It'll focus for just a second in the correct location. Yeah, that is a spectacular question. Is there a way for me to manually set the focus distance? All right, camera settings, camera settings. Camera control, focus. Nope, that's zoom, not focus, but I can do a little digital zoom on top of it, I guess. I wonder if I can leave that window open and close. Ooh, I can. Turn off autofocus. Hey, that actually looks like something. Manually adjust the exposure while I'm at it too. No, I don't want to do that. It'll do a 2x zoom in software, and that focus is about as fine grained as control as I can get. All right, I'm going to leave it like that. And then we'll see what happens as I get these. I need some of those glasses, I really do. Actually, I have a magnifying glass up here I can use to check some of these. Oop, that was a weird sound. So again, I am an amateur, but I do know that I'm not supposed to apply the solder directly to the soldering iron tip. I let the tip heat up the metal. I apply the solder to the metal on the other side so that I am not getting any cold solder joints theoretically. All right, I'm gonna go look at this under my microscope. I said microscope, I actually meant magnifying glass. Wow, it really is very hard for me to see. And this does seem to have had flux in it, by the way. I'm going to go ahead and put this back down here. You can see the coloring here. So I'm probably want some IPA or something to clean that off with at some point. I can see here where some of the solder actually came through to the other side. So that one's definitely got a good solder joint. I feel like they look good enough from what I can see that I'm going to carry on. By the way, all of this electronic stuff is a gigantic rabbit hole if you didn't know this. The sets of tools that you can buy. It took a lot of effort to explicitly pick a bunch of things that were through hole so that I didn't have to worry about doing any surface mount soldering. Although I have done a long time ago a little bit of surface mount stuff when I was doing some hobbyist hacking on a consumer remote control. All right. That looks pretty good and nothing looks bridged, although it kind of looks like I scorched the circuit board right there. Yeah, I did. My soldering iron must be too hot. I'm going to turn that down a bit and try to be a little bit more deliberate about how I get that on there. All right. Those are the dip switches. I said I wanted to do the resistor pack next, and those are all 2K resistors. My view of the stream, where I'm trying to monitor the stream, has it's not been updating, so please do let me know if something goes weird here. All right, 2K resistors, 2K. Those are the 2K ohms. And I simulated these in a simulator to make sure that 2K ohm was the correct resistance for my pull down. So, oh, and I just got these fairly nice nippers. Wonder if it makes sense to use them to cut this out of the, ooh, nope, it just pulls out. I need 8 2K resistors. Hope they were labeled correctly. Can you see the coloring on that enough for someone to verify for me if these are 2Ks? I cannot speak to whether about internships with electrical engineering is going to be a problem for you. Sorry. Yeah, that's a good. Oh, use your meter to read resistors. Hey, wouldn't that be smart? So these are supposed to be 2K ohm. I'm currently set at 2K. Coincidentally. Let's get that there. Good enough. All right, I don't need the set of dip switch banks anymore. Let's toss those back in the part. Ah, dang it. I forgot to put the... There we go. All right. All right, so these are 2K resistors. And yeah, I hear you when it says, when you're saying that I should put the lowest components in first. I also need some of that fancy tape, though. Where's my... How do I keep losing things? All right. If there's anyone here who can talk to Birken's question about, EE jobs and internships this summer, please do chime in the chat. Like any good engineer, I bought twice as many parts as I needed for every part of this build. Oh no, please. Oh, okay, good. Oh no. Look at that. Yeah, I'm gonna have to vertically. All right, so the pull down resistors spacing is wrong. See, this is a learning lesson for everyone, right? There's no way. If I pull that all the way down, it's just not going to go right. So I'm going to do the vertical mounting. Who was it who said the vertical mounting? You can always mount DBA. You can always mount the resistors vertically. Oh, I'm going to end up bending the legs, breaking the legs on this thing. Now I'm kind of curious if both of my parents are watching or if mom just chopped in, because I told my dad about this project just yesterday. So that's a reasonable option for vertically mounting this thing. That makes sense. All right. Let's just go ahead and do a few like that. Now I feel compelled to make sure that the colors are all in the same order. I have the red stripe down. I did actually do embedded engineering at my first C++ job. They asked if anyone was interested in doing the embedded part of a development project, and I immediately raised my hand and pretended like I knew what I was doing. And it was a great learning experience. Since then, I've always told people to volunteer for the things that you find interesting at work, because there's a very good chance that they'll just let you do it. Yeah, nothing fancy to break, because I have more than I need. By the way, the latency is way, way longer than it should be. I'm going to check a couple of things. No, it says ultra low latency. Wow. All right. Sorry, I'm just taking my streaming setup to make sure everything is correct. It looks like it's correct. I'm just still seeing one thing that says that this is unlisted, but that can't be right. Is that right? I hope it's not unlisted. Ah, no, it's public. All right, I'm good. I'm good. Okay. All right, sorry about that. All right, let's keep wiring in these guys. I think it's hilarious whoever compared me to Rosman a moment ago, because he actually knows what he's doing, and I do not. I very much do not know what I'm doing. I'm like a hobbyist who has been looking at electronics his whole life without ever actually doing anything about it. So this became one of my long-term goal to do items, was to actually make something once on my own. And I'm hoping that I got there. I'm gonna have to create a bodge wire to that power pin, and I'm gonna have to figure out how to wire in power in general. Something else I learned while doing this is that there is probably an infinity number of ways to did that way too tight, of different footprints for resistors, basically. So, David, do you ever miss doing the actual hardware engineering part of things? Trying to keep this in the camera as much as I can. All right, that is 8 resistors and my resistor pull down set. See, I had actually originally designed this as an 8 resistor pack, but then as I gave more thought to it, I'm like, you know what, the resistor packs are more expensive, and I have no idea what I'm doing. So I didn't think it ultimately made sense for me to get the resistor packs. But if you're looking at something like this yourself, maybe it would make sense in your design. That looks all right. Yes and no. I really liked programming. My school counselor said the software was harder to get a job as there were so many people going that direction. Oh, yeah, you know what? Oh, you want to know what the day of electrical engineer goes like? You've got to really be asking these other folks who are around here. I've worked with a couple of really great engineers, computer engineer, electrical engineer, when I told you I was doing those embedded development stuff at my first C++ job. And it's amazing how much difference it can make to have someone who really knows what they're doing with the layout. Like I specified the parts that I needed. I knew what chip I needed and I knew what kind of interconnect I needed. I was doing PIC programming, PIC microcontroller, talking to a ARM over a serial bus for the work that I was doing. Or just over a serial interface, not serial bus. I'm not scorching the circuit board anymore. Oh, that almost looked like a bridge. Gotta be careful there. I'm gonna have to check continuity across all these things when I'm done. Come on. You need to get cleaned off. Alright, it's nicely tinned though. Alright. Looks pretty good from this side. I'm gonna do a few measurements. I'm kind of surprised there aren't more people hanging around just to see if this is going to work or not. Oh, I mounted it so close to the board that I can't possibly get a connection on the other side. Let's just make sure I didn't do anything silly. All right. This is literally the cheapest multimeter that you can buy. I actually got it for free from Harbor Freight with a coupon deal. Oh, wait, these are actually connected. This would have been my resistor, what do you call it? Resistor pack on the other side. All right, so I have a new pair of cutters, snippers. I just got them 2 days ago. So let's see if I can avoid poking my eye out and nipping these off. No idea where it went. I should probably catch them. Oh, I cut that one tighter than I meant to. Right. I hope those were the right resistors. Okay. Yeah, that's true. You all could definitely buy, here, hold on a second. Here, check it out. That's all of Reiner's books, and he has been writing books for a while, so he has several. Be sure to check them out for sure. I did a translation review of the English version of one of these books at one point. Yeah, I remember when that was. It was all before C++ 20, that's for sure. No, you're saying you never saw me using Windows? Yeah, I actually use Windows all the time. I just use a Linux virtual machine for real work. It's a habit that I got many years ago when I first became a contractor, because it is very convenient to have a virtual machine per client, a full virtual machine per client. So there's no question about software, hardware configuration. I can set that up specific for each client. All right, these are my 1.5K ohm resistors, which are for the LED protection. .5K ohm. Let's double check them. You can't see the multimeter in your current view. Yep, 1.5K ohm. Let's see if they actually fit in the footprint that I chose for them. Here, I'm going to make one more comment here. And then I'm going to pin that. There. All right. De-dum. We're going to see if these fit. Do these fit? No, of course they don't. Why should they fit? But they might be a little bit better that I don't have to do the vertical mounting. Let's see what happens. Hear my dog pacing around upstairs in my basement. Always makes me nervous when I hear her pacing around. She's like 172 in dog years. Alright, that one's going to be somewhat vertical too. Alright, so all of my resistor... You know what? If I do this again, I might just do it with resistor packs. Just for the record, I know nothing at all about the personal finances of Reiner's family. I know that he lives in Germany, so hopefully he has good healthcare available. I expect that he does in Germany, is what I'm trying to say. Not like I'm trying to say anything bad about German healthcare system for sure. Um, that's a fair good point, DBA there. If you are at least moderately interested in AI and robotics. I actually wanted to get a degree in robotics. It was my first idea when I was in high school. I was looking at the Florida Institute of Technology because it was very close to where I was living at the time. Yeah, DBA, your comment here too, just now on knowing how to program will be very useful in most subfields. I actually just recorded an episode where I state that a computer science minor plus just about anything is a very valuable degree because everyone uses programming to solve jobs these days, solve problems these days. All right, one more resistors to thread in here. I have to go check on something, excuse me. My dog was just staring out the front door, and that's strange. I had a plan that one side of these was going to be green LEDs and the other side was going to be red LEDs, but I can't remember which one I planned where. But I'll be consistent. Well, you should subscribe to my YouTube channel because I do lots of stuff with C++ programming on here. It's fascinating, though, to see the difference in engagement I get for live streams now compared to the peak of COVID, where I could count on a lot of people hanging out for the live stream. All right. 8 more resistors ready to be soldered in with virtually no chance at all of a bridge. "99% of my knowledge is self-taught, 1% is from a university degree." It's probably true for a lot of people. I'm surprised at how often I still do indirectly use the knowledge from my computer science degree, because it taught me things that I wouldn't have chosen to have learned on my own in some cases. I feel like the lag is probably at least 10 seconds, and it's supposed to be set to ultra low latency right now. I'm assuming Qt still does copy on write because of historical reasons. All right. I see a little bubble of solder on the opposite side of each of these pins. Everything seems pretty sturdy. Snipping off. Extra wires so they don't get in my way. I got some nasty clumps of solder up here on a few of these legs. These nippers are really nice. All right. Yeah, that's a thing. Okay, so I said my main goal was to get to testing these input pins. Bits. So these are the register bits. These are the current value of the register that's stored in the, there's a 4-bit register chip in here. These are the input pins, which should be directly tied to these dip switches. So we're going to see if we can get those lighting up. That's my goal. All right, red or green? Someone tell me, should the current input values be red or green versus the current register values? The current values stored in the ALU in its single register, should those be red, or should the input values that I'm currently inputting be red? Those are my choices. While I find my LEDs that I will be using for this portion of the project. No, I don't want to mix them. My whole goal was to have two different sets so it was pretty and clear. I feel like mixing them would make it too hard to read the current value. Register to be red and the input value is green. Register red, input green. Alright, so those are my 4 green LEDs. Now I think I properly marked the footprint here. Register red, input green. That's what everyone says. Alright. It's the register. Eh? Eh? Anyone? Anyone? Where are you? I got like 8 of each thing because, like I said, of course I did. Part of the problem is that with DigiKey, you reach, you get more than 5, then the price gets cut in half, basically. So it costs like the same amount to get 4 LEDs. How much does it cost to get 5? Okay. I don't know which way these are supposed to go in. I'm tempted to hook power up to the board right now and test fit one of these with the dip switch set and get green glowy thing and then solder them all in. So I'm positive what the correct orientation is. That sounds like an idea, doesn't it? Look, I ended up with 5. I don't need 5. I think that sounds like an idea. I'm going to attempt to hook up some power to this thing. But I'm still at a bit of a loss as to how exactly I'm going to get power to it. Thinking about soldering a bodge wire off of here because the power goes all across the bottom of these 8 pins and here. So if I put one wire here and one wire here, and we can directly see that that's where that jumper is supposed to connect to. Yeah, the longer lead should be plus, right. So that should be this direction. Okay, sure. Oh, actually, let's do this just for the fun of it. Look at that. I got one thing right so far. Well, 2, because I also got these right. Yeah. All right. So I have things. I have parts that I haven't tested yet to try to make sure this part of the process goes well. All right. Come on, I know I've got a red wire in here somewhere. There we go. So if I just like solder a red wire like right here, maybe? Oh, I'm sorry. Is that better? Oh yeah, I had that whole thing out of view. I apologize. Someone should have said something sooner. All right, so I'm going to try to put a power wire here and a ground wire here is my current plan. I'm just going to verify a couple of things on my schematic and make sure that that's correct. Oh, no. That's... What is happening? How did I have this planned out? So the top thing here should be ground. That one should be ground. And the bottom one should be power. If that's... No. No, I'm positive that these are all power. And these are my pull down resistors. So this should be ground, that should be power. That's what I've been saying the whole time. Let's double check that. Because the pull down has to be tied to ground ultimately. Presumably the LEDs are good. They're all brand new, but that's a good point too. They might not be good after I do it wrong. All right. So I'm saying that these should all be power. And then these should all be ground. So that's this pin. Yeah, so ground is on that side. Okay, so ground here and power here, and never the two shall meet. Okay. All right, so let's see how I can get a ground wire bodged on. To here. This is way outside of my... Oh, well this part's easy, right? Because I could just solder all the way across all 4 of these pins if I really wanted to. Let's maybe not necessarily do that, but I could. All right. Ground and power. Ground and power. I'm a little nervous about doing this. Can you tell I'm all right. All right. This really isn't complicated, is it? I just need something to hold these in place. While it gets soldered. I'm going to trim that wire a little bit. Good enough fit if I can pick it up. And I'm going to go over here, I guess. Yeah, don't touch the soldering iron to your hand, people. Why do I want to do this one? I only have about 3 more hours at most that I can play with this before I have to get on to normal daily life stuff. Oh, that's terrible. Don't do that. I don't like that wire at all. Yes, exactly like that promo photo, that stock photo of the technician holding the wire, the soldering iron. Don't do that. I don't know what gauge wire this is. What? Stop that. Oh, come on. Why? Look at this. This is ridiculous. I was trying to pull the insulation off of the one side, and it slid the insulation down the entire length of the wire that I wanted to actually use. Now I've got... This is silly. I'm making a mess with little bits of wire. Next time I vacuum down here, it's going to go... Wah, 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 wah. There we go. Clean power wire. Yo, yeah, that's a good one. I have definitely inadvertently jammed things under my nails too. Alright, so let's see if I can get power approximately right here. All right, I have power, I have ground, I have a power supply for 5 volts with alligator clips. I haven't tested it yet. See? Tiny little power supply. Can you see that? Let's make sure it's in the camera. I ordered this thing. It's designed ultimately to be jammed onto a breadboard, and then you can choose whether you want the 3.3 volt or the 5 volt rails. On either end of it, it has this barrel DC power connector. Oh no. But what I am most interested in is this bit with the alligator clips. So I've got 5 volt and ground here. So I'm going to do 5 volt hot on the white. I don't know why they chose black and white, because in my head those both count as ground. But that should be 5 volt pinned in there. I have these extra rails disabled because I'm not plugging it into my breadboard. And I fortunately do have a power outlet and easy access right here. And I did design this whole thing for 5 volts, so hopefully it works. All right, power, 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 power. Oh no. the wrong orientation power plug. And that power plug is too far away. Oh, come on. Oh, this is silly. That's silly. How do I not have another power outlet that this will actually plug into? I'm going to have to do this. I'm going to risk hitting the power button on my power strip to plug this in. All right. It's plugged in. I didn't hit the power button on my power strip. That. Power on. Let's look at this. I've got ground. I feel like Doc Martin, or not Doc Martin, Doc Brown, powering up the model of the DeLorean and expecting it to catch on fire and go, ah! That's my current state of mind. Okay. So presumably this thing is hot. Let's turn this on and see if we measure from ground to power. Oh, that's resistance. That was a mistake. DC 20 volts. From ground to power. 5.05 volts. Very good. All right. So from this pin to here is 5 volts. This pin to here is 0 volts. Okie dokie. All right. So it looks like my switch logic is inverted, which I kind of wondered might be a thing. But that does send 5 volts here. And let's look at resistance, because I should be getting that 1.5 kilo ohm resistance. Oh wait, what just happened? That's saying 5 volts. Oh, because I'm measuring from the input side, not the output side. Oh, goodness gracious. All right, the switch is doing things. It's doing things. It's doing things. All right, let's attempt this green LED. Thank you, Dennis, for the donation. I'm just going to kind of hold it because it's 5 volts, a low DC current. Yeah, no low. I screwed up on several things. All right, I'm going to turn this back on. I'm going to turn that. Ooh, look! The switch turns the LED on and it doesn't blow up. Ooh! Let's solder in some LEDs, shall we? Ah! Hey, if nothing else, it's a little thing that can turn lights off and on. Oh, the important things. All right. All right. Very good. First set of bodge wires are a go. I need to make sure I bodge power over to that pin, but I'm going to do that after I put the sockets in. I'm going to do these LEDs across the top, at least just the input indicator ones. And then I'm going to do the sockets, I guess. See, I knew you all would stick with me just to see the... I need better light. Just to see the LED come on. It's ridiculously gratifying to see, you know, just the tiniest portion of this project that you spent. Well, you know, I spent actually surprisingly little time on it because I already knew what the circuit was supposed to do. And everything explodes and starts to burn. I try not to do that. It's my goal. Oh, I bent the legs backward. My LEDs are cross-legged. All right, longer pin here. It means several things. It means that my resistors are correctly soldered. It means that my chips are correctly, or not chips, my dip switch arrangement is correctly soldered in. All right. You know, I just realized I didn't ask Reiner for permission at all to do this. Probably should have. But not giving them, just raising money for ALS. It's a good shtick to have your stuff always blow up. That's a good way to get YouTube clicks. I've let out no magic smoke so far today. All right. He only once almost killed himself. In the list of things people I hope people don't say about me. All right. Ground. Power. Power on. Boop. 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 Ah! 4 little lights turned on. Oh, it's way more satisfying than it should be. Alright, let's avoid shorting anything and trim these wires. Guess I'll do the... No, I'm reluctant to do the current register LEDs until I have the chips in, I think. If that one bodge to power on the ALU is all I need, I might get this working in the next couple of hours. How long have we been doing this? How long have I been doing this? Oh, 1 hour and 43 minutes. Oh, wow. Pretty successful attempt so far for someone who has no idea what he's doing. Oh, it almost looks like I cut that trace with my nippers. What the heck? I really hope I didn't. That'd be incredibly annoying. Just make sure that I didn't damage that so I don't worry about it in the future. Okay, those are still turning on. All right, cool. Image retracted. Okay, sockets. Let's do sockets. Let's do sockets. I've got 1, 2, 3 smaller sockets, I think is how this is. I only bought sockets, so my plan was that I could ultimately build... Wait, what? Which size socket is that? Oh, that's the bigger one. My plan is that I could ultimately build more than one of these things and give a couple away at conferences just because it would be fun to give stuff away at conferences. This is not holding itself in nearly as well. I'm having to bend the socket pins because I don't have any tape or any reasonable way of holding this in. I don't really want to do that, but here we are. Oh, oofda. If I could set something underneath this. What do I have to set underneath that? Don't want to ruin that. Don't want to ruin that. Oh, whatever. Anyhow, I thought it could be fun to give away a couple of completed boards at conferences just to do it. All right. I have no idea why I just picked the one in the middle to start with. Let's see what happens. Ooh, that's how I'll bodge the power to the ALU. I'll just jumper across from one power pin to another on the bottom of the board. That would probably make a lot of sense. I don't know if you noticed, but these wires that I'm using are quite a bit thicker than what one would normally use for a bodge wire, but it's what I've got on hand at the moment. Come on. Like sinking a lot of heat on that. Having to hold it longer than I expect to. What is happening? More thermal capacitance on the pins. On my, yeah, no, all of that solder went straight onto the solder tip. I can tell from here it didn't go in the... There we go. There we go. Those look good. I have to check the socket and make sure I'm not... You see that little piece of solder that went right there? Can you see it on the video? Probably not. So anyhow, as I was saying, I bought enough parts that I could build more than one of these, but only enough sockets for one of them, because I figured if I can test the design with one, then I shouldn't need the sockets on the follow-up ones. But I have no idea if I'll actually have the energy or interest in making more than one of them. I don't want to bend the pins out on this one, but if I don't, it's going to fall out of the through hole there because I didn't put the shallowest parts on first. Yes, yes, I know. But I really wanted to make sure that I had the rest of the setup how I needed it. Put some flux. I don't have any flux. Sorry, you missed that at the beginning. I don't have any flux. You know what I'm going to do? I'm tempted to just grab some like normal clear Scotch tape to hold these in while I solder them, but I'm afraid that that'll just make a mess if I do. I wonder if I can just put my nippers underneath here. It's holding that socket in place. It's not holding both sockets in place unless I push pressure right there. There might be something to this idea. Someone else made a comment about making sure you just got the two corners done. That should do that. Blue tack. I probably actually do have some blue tack. That's the kind of thing that lives in the junk drawer in the kitchen. But that worked. That did work. I'm going to get this one also tacked in. And then I'm going to go back and do the other million pins here. If I were to keep doing this, I might want some sort of ventilation in this place. Okay, those are tacked in, and I can use that safely now. Why did I solder the resistors vertically? Someone who's been around longer can know. Because they wouldn't fit. I designed my layout poorly. So that's what I had to do. I messed up because this is the amateur who has no idea what he's doing. Thank you so much, Khalil, for the donation to the ALS therapy people. I think I'm leaving solder balls behind. Yeah, it's just, I don't know. It made me uncomfortable bending the pins of these. Hello. I can see that you're not. There we go. All right. Oh yeah, that one was ugly. All right, that I think. Don't love the, whoa. Don't love the look of a few of these. But I need magnification of some sort to be certain. All right. One more of the long. And then 3 of the short ones to do. Thanks, Doug. I don't know if I'd turn this into Hardware Weekly necessarily. I'm not looking to do that. But I always think it's good to expand people's education as much as I can be responsible for such a thing. Like overall, this is going faster than I expected it to. And it'd be shocking if the thing actually works from the beginning. Although there is one key feature that I completely, totally left off. And it's ridiculous. And I don't even know what my solution is for it at the moment. But the flip-flop, which is my 4-bit register, needs a clock signal. And in the original design for this thing, yeah, I think this solder does have flux. The original design for this thing had a momentary push button for the clock signal to manually drive it. And I did not wire up anything to the clock pin. Yeah, the solder must contain flux because it's leaving behind like oily spots here. I'm going to set up a fan. All right. So let's double check that actually. The LS 175 clock pin. I'm going to go back over to my desktop and all right, so that's the adder. The carry out is intentionally not connected to anything. Whoa. 153, 153, 175. Okay. So that's, oh, you are zooming all over the place, aren't you? Yep, the clock signal. Not connected to anything. Neither is MR. I need to look at my original design from college. Oh no. Missed that. This is a memory reset, and it's negated, and it's floating. So it needs to be tied high to stop it from floating, which means I should have put, oops, I should have put a plus 5 volt down here. So pin 1 needs to be tied to 5 volts. And pin 9 needs to have a bodge wire for the clock signal. All right. Yeah, safety first. I have a fan blowing at my station now, so it'll keep air circulating around. Let me know if you hear the noise on the audio input. No, I think it's doing a good job of filtering that out. My noise filter is. I'm going to go refill my beverage though, and I will be back again in just one moment. And I need to make notes about those two mistakes. All right. So the LS 175 pin 1 tied plus 5 volts. So now I need to connect 175 pin 1 and the adder, which is over here. That is its pin 16. That says pin 16. Is that right? Yeah. Okay. Pin 16. Just counting the wrong way around. Pin 16 on the adder. So that's this pin. That's my adder, because I have it kind of as the output stage for all of this, which isn't 100% accurate, but that's how I laid it out. So the output of the adder gets fed back around to the inputs of the flip-flop. So pin 1 of the flip-flop, which is going to be this pin, of the ALS 175, which is, yeah, U3. So pin 1 of U3 and pin 16 of U4 both need to go to power. And you can actually see the unconnected traces here, I think. That one is definitely right. I'm going to do the update schematic button. Connect U3, pin 1. All right, plus 5 volts, yes. Update PCB. All right, so now we can see that faint trace here. All right, so U3, pin 1, and U4, pin 16. Those are the ones that I ultimately need to make bodges for. And then I need the clock pin, which is pin 9. Pin 9 on U3. All right. All right, let's get back to putting in these sockets, and then I'll have something to actually attach those bodges to. Yeah, I finished all those, I think. I am done with that parts tube entirely. And let's put back on camera mode. Camera. All right, camera mode. There we go. Yay, 3 more sockets to solder. But given that I've already done 4, doesn't seem that bad. Oh, come on. You give me a little click here. What is happening? Look, this socket has these little pre-bent clip dealies. Do you see that? Are they all like that? They are all like that in this one. Oh, that is fantastic. It held itself right in place. I wonder what I chose differently on that part. Oh, goodness. I have to go look that up. Oh, that is amazing. They're just holding themselves right in place. Nice. I only have 14 times 3 pins to do. Oh, that's these 3 sets right here. Yeah, I don't know. You probably couldn't hear it, but they actually went snap, snap as they clicked into place. It was amazing. All right, so the ALU needs power. All right, let's get these in, and then we'll figure out those bodges. Okay, somehow the flux streams are still going straight at my face. Oh, goodness. All right. It's really, truly impossible for them to go straight at my face right now, but I won't be surprised at all if the fan is picking up some of those notes. It looks like it's getting some of it. You all tell me if it's a problem. I should try Top R PCB Tracer. I don't know what that is. Is that a software package? Alien garble noise detective. Is that actually, can you hear me or not? Is it a problem? That's bad. Okay, according to my input mixer, you're not getting any noise at all right now, and I have a fan blowing up my nose, which is probably a good thing. Okay, all right. Yeah, I don't need to get lead poisoning. I didn't even notice it until I got to the point of um, doing all of these pins on the sockets. All right, almost done with the bulk of the soldering. Just have to connect those 2 extra pins that need to be pulled high constantly. Well, the one that needs to be pulled high and the one that needs to have power. It's the same thing. Wait, did Darth Vader ever tell me what top OR PCB tracer is? No. Might have been when the audio was garbled when I asked for more information. All right. That is all of those. All right, so pin 1 of U3. That's U3. Pin 1 is this pin. And we can see it actually has a square pad, if you can see that. So that gives us some extra info. Now, I need to get a wire soldered on to pin 1. This is where I really need some of that fancy tape that holds electronics in place while you solder them. So these are power also up here. So that's like my main power rail over there. I wonder if I can somehow because all of those are power. Every single one of those pins. I even have that bridged across 2 of them. Those are all power. These are all power. I'm kind of thinking about something like this. Routing it like through the resistor pack just as a way to hold the wires in place. No, that doesn't look like it's gonna work. Can like take advantage of the springy nature of these wires. Ooh. That looks like it's gonna work. I think that is gonna work. All right. I just have to make sure I'm not bridging pin 2 of U3, and I'm pretty sure I'm not. All right, that's fine. Just have to be super careful here now. All right. Sorry to set the mic. Looks like I got power to pin 1 of U3, does it not? I'm pretty sure I did. All right, so I need to get power to, what was the other one? Someone remind me. U4, pin 16. So pin 16 of U4 is this top one up here, which now is going to become the bottom one, which means it's this pin, and I need to get it over to power as well, which would work for that bus, or it would work for, actually, no, there's no other power, tied power on U4. So pin 16, so pin 8, that was ground, pin 16 is power, yeah, okay, so this one, pin 16. All right, pin 16 to any other pin 16. I could tie it to this one, I think. So this one should be power, right? That one should be power because that one needs to be power. So let's double check that. Continuity here. That one. No, that's the voltmeter. Let's put it down on ohm meter mode again. So that one should go here. Should go here. Which should go here. Okay, so if I tie that one and that one together, that should be a nice way to get power to that pin. Well, the wire that I picked is a little bit longer than it needs to be. All right. We need here. Do the same trick that I just did and kind of route things like that, maybe? I don't love how this is going. Wait, that's all right. I think that's all right. I can get power there and then I can rearrange the next one to get the next power. Of using your fingernails for too much. Don't like how this is going. I think it's gonna be okay. These are some of the pins that I bent down. Oh, dadgummit. Is this being more difficult than I want it to be? Okay, that looks okay. Good thing these aren't like high frequency wires where I have to worry about like crosstalk or other complicated things. That is just making a solder bubble. Come on. Oh, that is terrible. That is a terrible solder job. Ow, crap. Ooh, that was hot. Get off of there. It would appear that my wire strippers are somewhat magnetized. Let's try this again, shall we? It's probably fine, but oh goodness. Alright, that was a pain. That was more of a pain than it should have been. But I should have continuity from power to that pin so that my reset line is tied high. My inverted reset line is tied high. There, I do. I have 0 resistance between those pins. So, yay. So now I need the clock wire hanging loose and free. And so let's get another chunk of wire for that that's insulated. I think this is the only one that I intentionally want relatively long. All right, so the clock wire on the pin 9. Pin 9 on U3. Pin 9 on U3. So that's 1, 2, 3, 4, 5, 6, 7, 8. 9? No, 9. It's the one opposite corner of the square pin. It's this one right here. And look, even just looking at it, I can see it's not connected to anything. So this is going to be my clock wire. Yeah, that's going to be my clock wire. I don't know if I want red, though. Whatever, I only have so many pre-cut wires. So this pin, right? That's U3. That is U3. It's the one opposite of the pin 1. That is this one. That's the one opposite pin 1. All right, I'm gonna do that trick with the pliers like I did a moment ago. Oh wait, I had to actually get solder on the pin for that to work, or on the wire. Needed to tin the wire. Let's do that. Let's see if we can tin this. No, this is terrible. What am I doing? Oh, no, 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 no. Oof. All right, I have to take another break. I'll be back. I'm actually going to hit the intermission button in a second here.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
It's 4 minutes till showtime.
Hey, fellas, don't fight over that hot dog. There's plenty for everyone. Big, plump, and juicy, wrapped in an oven-fresh bun. Add mustard, relish, ketchup, and go to work. Yes, the hot dogs at our refreshment center are the best you'll find anywhere. Everybody agrees on that.
It's 2 minutes till showtime.
Your attention, please. All new hotshot electric in-car heaters have been installed for your comfort and convenience. Just insert heater through car window and turn on the switch. When leaving, please turn switch off and replace on speaker post. Warning, high voltage. For your own safety, do not attempt to repair or remove wires. Do not attempt to open heater unit. If you need assistance, please notify the theater box office or concession manager.
Top quality hamburgers, the most popular snack in the country. We serve them plain or garnished to your taste.
And now, on with the show.
You've seen the show. It was quite a treat. But now you'd like something to eat, so right this way to the concession stand serving Castleberry's, the best in the land. Yes, sir. Castleberry's is real southern barbecue. Choice cuts of meat slowly cooked over open pits of smoldering oak coals for honest-to-goodness barbecue flavor. You'll also find hot coffee, cold soft drinks, and delicious ice cream in our snack bar to go with your Castleberry sandwich. Just look at that generous helping of rich, juicy barbecue. Yum, yum. For a real taste thrill, Castleberry's barbecue will fill the...
Golden, pure creamery butter, rich, flavorful, satisfying. That's what it takes for the finest buttered popcorn, and that's what we use. See for yourself why there's no Showtime treat to equal the crisp, delicious flavor of hot popcorn that's bathed in real melted butter. It's at the concession stand now.
You don't have to just dream about Dairy Queen. Your favorite Dairy Queen treat is a refreshing reality at your nearest Dairy Queen store.
Hey! They're ready, folks. Visit our refreshment stand right away for delicious orange crush and all kinds of good things to eat.
Let's play Dutch treat. Da 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 da. Oh, you're it. No, I'm not. Come on. I'm it. 1, that's 2, that's 3, that's treat. 4, that's 5, that's 6, that's treat. 7, that's 8, that's 9, that's treat. That's treat chocolate drink. Oh, that's treat chocolate drink, please. That's treat drink so good. I want some. Me too. Everybody loves it. So good. It's good hot
or cold.
Mom and Dad love it. So, get that treat chocolate drink at the snack bar now.
Still plenty of time to come and be served at the refreshment center before showtime.
With mustard and relish, you'll guarantee mouth-watering satisfaction. And now he slips his costume on a beautiful golden bun. There's his cue to go out on stage.
He's the natural.
He's the rage. Meet this personality at our refreshment counter. Treat the family.
Something different for a change? Then try the perfect refreshment. Chili Dilly, a delicious pickle treat that's spiced just right for every bite. Economical, too. There's no waste. You eat every bit of the juicy goodness of Chili Dilly. How about trying one right now? Chili Dilly, on sale at our concession stand. You'll love 'em.
You have 5 minutes till showtime. Time for refreshment. Refreshment. For your enjoyment, there's hot, fresh popcorn, tempting, delicious hot dogs, and so many kinds of ice cream. And, of course, sparkling, delicious, ice-cold Coca-Cola for everybody at the refreshment counter now.
It's refreshment time, folks. Time out for a delicious snack in our sparkling refreshment building. Every item a fresh, appetizing taste treat. Fresh popcorn, delicious and crisp, with or without butter. Sizzling hot dogs, bursting with juicy goodness. Tender, tasty hamburgers with all the trimmings. French fries, crisp and golden brown. Thirst-quenching, refreshing, ice-cold drink.
There's plenty of time to treat yourself to something good to eat at our refreshment center.
The show begins in just 4 minutes.
Our hamburgers are the finest. Quality beef expertly prepared for extra deliciousness. Treat yourself royally right now. What a hamburger.
You get more out of life when you go out to a movie.
Our tempting, tasty French fries go with everything. Come and get them. They are hot. They are delicious.
Save your battery and your disposition. When it rains, you can still enjoy the movie with a Drizzle Guard rain visor. Simply press suction cups to the windshield as shown in the detail on your instruction sheet. Drizzle Guards are on sale now at the concession stand.
Refresh yourself. It's intermission time. The concession stand is open and ready to serve you.
We feature ice-cold drinks at our concession.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
It's 4 minutes till showtime.
Hey, fellas, don't fight over that hot dog. There's plenty for everyone. Big, plump, and juicy, wrapped in an oven-fresh bun. Add mustard, relish, ketchup, and go to work. Yes, the hot dogs at our refreshment center are the best you'll find anywhere. Everybody agrees on that.
It's 2 minutes till showtime.
Your attention, please. All new hotshot electric in-car heaters have been installed for your comfort and convenience. Just insert heater through car window and turn on the switch. When leaving, please turn switch off and replace on speaker post. Warning, high voltage. For your own safety, do not attempt to repair or remove wires. Do not attempt to open heater unit. If you need assistance, please notify the theater box office or concession manager.
Top quality hamburgers, the most popular snack in the country. We serve them plain or garnished to your taste.
And now, on with the show. You've seen the show. It was quite a treat. But now you'd like something to eat, so right this way to the concession stand serving Castleberry's, the best in the land. Yes, sir. Castleberry's is real southern barbecue. Choice cuts of meat slowly cooked over open pits of smoldering oak coals for honest-to-goodness barbecue flavor. You'll also find hot coffee, cold soft drinks, and delicious ice cream in our snack bar to go with your Castleberry sandwich. Just look at that generous helping of rich, juicy barbecue. Yum, yum. For a real taste thrill, Castleberry's barbecue will fill the...
Golden, pure creamery butter, rich, flavorful, satisfying. That's what it takes for the finest buttered popcorn, and that's what we use. See for yourself why there's no showtime treat to equal the crisp, delicious flavor of hot popcorn that's bathed in real melted butter. It's at the concession stand now.
You don't have to just dream about Dairy Queen. Your favorite Dairy Queen treat is a refreshing reality at your nearest Dairy Queen store.
Hey! They're ready, folks. Visit our refreshment stand right away for delicious orange crush and all kinds of good things to eat.
Let's play that street. Da 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 da. Oh, you're it. No, I'm not. Come on. I'm it. 1, that's 2, that's 3, that's treat. 4, that's 5, that's 6, that's treat. 7, that's 8, that's 9, that's treat. That's treat chocolate drink. Oh, that's treat chocolate drink, please. That's treat drink so good. I want some. Me too. Everybody loves it. So good. It's good hot
or cold.
Mom and Dad love it. So, Get that street chocolate drink at the snack bar. Now.
Still plenty of time to come and be served at the refreshment center before showtime.
With mustard and relish, you'll guarantee mouth-watering satisfaction. And now he slips his costume on a beautiful golden bun. There's his cue to go out on stage.
He's the natural.
He's the rage. Meet this personality at our refreshment counter. Treat the family.
Something different for a change? Then try the perfect refreshment. Chili Dilly, a delicious pickle treat that's spiced just right for every bite. Economical, too. There's no waste. You eat every bit of the juicy goodness of Chili Dilly. How about trying one right now? Chili Dilly, on sale at our concession stand. You'll love 'em.
You have 5 minutes till showtime. Time for refreshment. Refreshment. For your enjoyment, there's hot, fresh popcorn, tempting, delicious hot dogs, and so many kinds of ice cream. And, of course, sparkling, delicious, ice-cold Coca-Cola for everybody at the refreshment counter now.
It's refreshment time, folks. Time out for a delicious snack in our sparkling refreshment building. Every item a fresh, appetizing taste treat. Fresh popcorn, delicious and crisp, with or without butter. Sizzling hot dogs, bursting with juicy goodness. Tender, tasty hamburgers with all the trimmings. French fries, crisp and golden brown. Thirst-quenching, refreshing, ice-cold drink.
There's plenty of time to treat yourself to something good to eat at our refreshment center.
The show begins in just 4 minutes.
Our hamburgers are the finest. Quality beef expertly prepared for extra deliciousness. Treat yourself royally right now. What a hamburger.
You get more out of life when you go out to a movie.
Our tempting, tasty French fries go with everything. Come and get them. They are hot. They are delicious.
Save your battery and your disposition. When it rains, you can still enjoy the movie with a Drizzle Guard rain visor. Simply press suction cups to the windshield as shown in the detail on your instruction sheet. Drizzle Guards are on sale now at the concession stand.
Refresh yourself. It's intermission time. The concession stand is open and ready to serve you.
We feature ice-cold drinks at our concession.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
It's 4 minutes till showtime.
Hey, fellas, don't fight over that hot dog. There's plenty for everyone. Big, plump, and juicy, wrapped in an oven-fresh bun. Add mustard, relish, ketchup, and go to work. Yes, the hot dogs at our refreshment center are the best you'll find anywhere. Everybody agrees on that.
It's 2 minutes till showtime.
Your attention, please. All new hotshot electric in-car heaters have been installed for your comfort and convenience. Just insert heater through car window and turn on the switch. When leaving, please turn switch off and replace on speaker post. Warning, high voltage. For your own safety, do not attempt to repair or remove wires. Do not attempt to open heater unit. If you need assistance, please notify the theater box office or concession manager.
Top quality hamburgers, the most popular snack in the country. We serve them plain or garnished to your taste.
And now, on with the show. You've seen the show. It was...
All right, I'm back. Sorry about that. So I just connected the clock wire. Save the clock wire. And I got my bodges in, power to my chips, and well, let's see what happens. Oh, wait, I should. Shoot. Should I do the LEDs first? I don't know if I should do the LEDs first, or if I should plug these chips in first. I guess I'm going to trust that I did these LEDs at least mostly correct. Really want... Ah, shoot. All right, I'm going to try to load... And this is what I'm going to do. I'm going to put in one of these pins, one of these LEDs. I should have put the chips in first is what I should have done. All right, I've got my schematic in front of me. So I know that the 283 is U4. That's the one that goes here. I just have to find the 283. That's the 175. That's the 283. Those of you who were here in the beginning, I did I did tell you all that I bought basically 2 of everything, or twice as much of everything as I needed, just in case I blow up something. So I am putting in first the 4-bit adder. Okay, what is happening? All right, the 4-bit adder. The 4-bit adder, that somehow seems to be a different pitch than the socket that I have, and I know that can't possibly be correct. So there we go. 4-bit adder in place. 283. All right, so these are both 153s, which are multiplexers. All right, so I should be the one that I have the 4 of. One, 5, 3. Yep, okay. So that's that chip and that chip. Now I'm going to be ridiculously proud of myself if this thing actually works when I'm done with this. Alright, I just bent in the pins ever so slightly. That is the 153. And that should go in here. Ooh, I did a good job bending those pins, making them straight, basically. That went straight on. Alright. One, 5, 3 into U2. All right, good, good. All right, U7 is one of my NANDs. So these three are NANDs. Oh, thanks a lot, DBA, for hanging around. I'm so close. I can taste it. Yeah, all right. All right. What is it? There's quad NANDs. So there's 8 inputs, 4 outputs per NAND chip. And then my last chip is the 175, which is my 4-bit flip-flop, which I use as a register. 4-bit register, 4-bit processor, inputs and outputs, all aglow. I should turn the soldering iron off. What do you think? It's been running hot this whole time, even while I took my break. All right, that's all the chips seated in all of the sockets. Wow, it actually looks like a thing. So remember, this is my clock wire. And I don't know what's going to happen if the clock is floating right now. So I'm going to tie... No, I don't know how I'm going to do this. I'm going to just manually move the clock from like high to low. All right. So I turn this thing on, and this directly shows my input state. So I am going to attempt to load the value 1 into my output register. So if this is doing its job at all, I need to make sure I don't short ground and hot here. So I don't have any color coming, any light coming here. Now my opcodes say if I want to hold. No, not hold. Shift right, add, increment, clear, imp. Wait, I need to know what my load opcode is. Oh, that's an idea. Yeah, I could. That's a good idea, Bjorn. I could just rig up. Well, all right. I want to try indicator. I'm so confused. Oh, I want to add. I'm going to add because it's currently at. Okay. So clock is ground. All right, I'm going to tap. I have no idea if I've even got this in the correct orientation. I think I do. Okay. So I think what just happened is I added 1 to 0. Now if I add 1 again, then that's 0. If I add 1 again, then that's 1. Okay, I think this is doing its job. I'm at least able to add. I'm going to go ahead and solder in these red LEDs so that we know that it's not like some sort of weird short or something. And then I'm going to do this manual game. Now, pull down resistor is what I had spec'd at 2K ohm. And I know that I've got those spare ones. So what Bjorn was just suggesting is that I tie this to here. Yes, this to here. with a 2K ohm. So the clock will be pulled low. And then I can tap to power whenever I want to increment the clock. That was Bjorn's suggestion, and it sounds like a good one to me. But let's go ahead and get these red LEDs in here. Sorry for all the little coughing and sniffling. I have this very minor sinus infection I've been fighting. I just realized for far too long. Probably about 4 weeks. I just talked to the doctor last night, finally. It's the kind of thing that's minor enough that I just kept like, oh, well, you know what, it'll probably clear up tomorrow. And it didn't. Oh, I need my soldering iron on. Good thing it's one of these things that charges up quickly. Just got a message from my cousin. Figure that out while my... Oh, that's very nice. All right, let's solder. I'm gonna have to get myself a momentary push button. All right, those are wired in. Not very attractive, but it's fine. I have like a boneyard forming over here. There's so many little nipped pieces of metal. All right. So that's the add instruction. All right, let's get the 2K ohm resistor. Where did I put my baggie of resistors? Nobody knows. That's my 2K ohm resistors. I found them. I think I bought more than I needed of these. But I don't need... Alright. So the 2K ohm resistor is going to be the pull down on the clock line, so it needs to go to ground. So what we're going to see is... I need another wire. I need another wire, and I need a way to tie these together. I don't know if I have another alligator clip. All right, so I want this side and this resistor all tied together. Need a wire tie. Yeah, I need a wire nut. How am I gonna do this? All right. So the other end of this resistor, oh, it already fell apart. Do I just solder this all together? Because otherwise I'm gonna... You know what? I'm not going to do this just yet. What I really want is a momentary push button that ties this wire to either high or low. I'll have to just order one of those. I don't think I have one of my parts. Pull this out. I'm afraid I'm at risk of breaking that wire off. All right, so ground and power again. Now, if I have this correct, then my output register is not 0. All right, let's go. What is happening right now? I've got too many wires in play. Okay, so that's now tap the clock. Tap the clock. You're right, Bjorn. I don't know what's happening. It's too much floating around. You're right. So I am going to go ahead and solder these things together. Where the heck did my resistor go? It's probably like underneath this messing with me right now. Where did that resistor go? Come on. Can anyone see it? I literally just had it here. What did I do? This is ridiculous. Gotta be somewhere, right? Fine, I'll get another resistor. Oh, there it is. Okay. So we were saying that we need this jumper wire, this resistor, all tied together, right? Like this. Yeah, I'm getting multiple. I agree that that is what's happening. So that's why I'm going to go ahead and go with your suggestion of the very least, I'm going to, even if I don't solder these together, get a really good twist on them. Okay. All right. So I am taking the clock wire And I am making it low. And now I have, as Bjorn suggested, a way to tap the clock. Tap, tappity, 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 tap. And yeah, it's going to bounce. But let's start with this and see what value we've got. I should have some way of hitting a reset on the right, that's the wrong wire. That's the correct wire. All right, that's a pull down and a clock tap. Tappa tappa. Oh, that's not good. That's not good. Oh, I wired it backward. Oh, yeah, I did. Oh, goodness. That should be ground. That should be positive. I got an error signal on my power supply. All right. So I should be adding 1 each time I do this tap, but I agree that it looks like I'm getting bouncing. So let's try this. The hold. Look at that. Wait, why did you just stop that? Oh no, what is happening? Is the clock signal inverted? No. I need to look up the SL175. Not 275, 175. Pin 9, CP. Okay. This one doesn't show the bar on the memory reset. This one does. Active high going edge input. Active high edge. All right. So this input right here, 0, 0, 0, 0, should mean that the output always stays the same. That's how this was designed originally. That does not appear to be the case right now. The fact that just changing these switches the switches should all be pulled down to low. That should be where they are right now. That's this pull down resistor block right here. Pulls all of these get pulled down to low. That's clearly ground. That's ground. My clock signal is pulled down to low, and my clock should only be incrementing when I tap pi. I'm going to pull up the data. That's a picture of the data sheet. That is not the same thing as a data sheet. Oh, I have... Yeah, definitely in my very original ever diagram for this, the one that I actually passed this class with, the clear was pulled high. That's one of the bodge wires we did. That's pin 1. Let's just test a couple of things here. Let's make sure that pin 1, clear pin, is actually high. Turn off my soldering iron. All right, debugging time, people. 20 volt DC input. And we're going to check our bodges and our connections. So pin 9 is that pin, right? Yeah, something is floating that shouldn't be. Look at that, just tapping pin 9. That's not good. All right, pin 9 should be ground. Right now. Huh. You know what? I'm just going to try the old reseat all the chips kind of thing here. The fact that tapping anything at all against that clock wire makes things change. Did I accidentally short the clock wire? Sure as heck seems like it should be floating correctly. That flip-flop is super sketch. It's... The clock... What is happening? Agreed. But tapping any pin is screwing with things. Now, so the ground pin should be... Which one? This should be the ground pin. This should just always be ground. I wonder if when I first hooked up power backward, if I toasted this one particular chip. Is the chip powered? You know what? Let's check that. Okay, so ground seems to be ground. And, well, measuring voltage from power to ground gives me 5 volts, so I believe that the chip is in fact powered. Let's do the same thing on all of these chips. Yeah, alright, so measuring across power to ground gives me 5 volts on all 7 chips. Alright, the clear pin, that's the one that's pin. That's measuring a solid 5 volts.
Call from Jen.
The chip is powered. That chip is acting really weird. Just for the fun of it. So when I hooked up the power backward the first time, the power light on my power supply started flashing. It clearly indicated a fault of some sort. Does it seem even possible? I mean, look, everything seems just a little goofy. Oh, sorry. I'm going to take some of the light off of it so you can see the LEDs better. Are those pins inputs? Maybe, but either way, the output shouldn't be changing because its clock is currently being pulled low. So the only thing I can hypothesize is that my pull down resistor of 2K is too much resistance. I'm going to look at something. Yeah, Pull down resistor for 5-volt TTL logic, right? I verified this and tested it before I built this thing. I'm searching the internet right now. Two kiloohms. I mean, that's what the internet says to do as well. Yeah, I mean, did I possibly damage all of my chips at once? Do I need capacitors across the 5-volt and ground connections to each chip? I don't think so. My original breadboard version of this didn't have anything like that. Well, I might have to give up on this. Or start swapping out chips and see if I really did fry it. So these are SN74LS175. SNLS chips. Having bypass caps could help. I'm going to pull up the product sheet of what I'm using so you all can participate. Technical documentation. Data sheet. This is the quad flip-flop that I'm using. Clear, clock, individual data input, pattern generator, okay, blah, blah, blah. Max frequency, 40 megahertz. Well, we're running slightly lower than that. I don't know what I'm looking for. I have no idea. Capacitors tend to suppress impulses on the power that can cause random bit flipping signals. I just remember building an 8080 computer. All right. I've seen suggestions of putting 220 ohm for pull down. All right, let's Google specifically. Unused high inputs with multiple emitters should be connected to VCC. No, that's for 74S and 7400, not for LS though. In the 7400 LS series, an input signal between 0 and 0.8 is considered low, and input signal between 2 and 5 is considered high. No one just gives you a straightforward answer. I'm going to just measure some stuff, and then I'm going to consider swapping out the chips, and if that doesn't work, then I'm going to stop messing with this for today. Okay. So what we want to know is the voltage across these things. Oh, that's actually illuminating. That's 0.45 volts across this pull-down resistor. Okay. So that is within that range of being the value 0, but like just low value 0.07. Yeah. It's kind of, it seems like it might be a little high. So the input that I have set at the moment should be I don't know what that should be. 0101. That's the shift right of A plus B. Oh, that's complicated. Ooh, let's try this one. Yeah, the fact that moving those switches, they should never change the output value because the clock hasn't been triggered. Now, we clearly don't want the clock floating. But on the other hand, it's only supposed to trigger on the rising edge of the clock. That's still stable at 0.45. Ooh, that's actually really interesting because it's currently set on clear the register. And no matter what I'm doing, it's not triggering anything. The register is staying cleared. The clock pins. There's only one clock pin. The only clock pin is this guy. So it's 0 out. It's clear. Ooh, let's try this one. This operation is increment. Now, notice when I turned it on, it incremented. As soon as I switched it, it incremented. What did I do wrong? Let's try triggering this clock signal. It is like it's bouncing and adding like 1,000,000 to it each time. So if I Let's go back to clear. Yeah, what the heck? Switching it to clear. But it's only... I don't think I fried the chips. I think something weird is happening with the clock. So the clock, let's measure it straight off of the chip instead of off that clock wire. So this is the clock. I'm going to attempt to make this visible to you. And that is ground. So that is at 0.45 volts with a 1.5K ohm. Wait, no, I grabbed the 2. That's weird. Yeah, that's the only chip that has that's the only chip that has a clock signal. It's the latch for the flip-flop. So that's when it loads its new input values. So if I were to yes, that is what it's doing. What are the other chips? They're all 7400 series TTL, 7400 NANDs. These are 7400 NANDs. These are multiplexers to select which input I'm loading. And this is the adder. So these all things switch which bit is currently being selected to go into the adder, and then the adder's outputs get fed back into the latch. And then the latch only loads those values from the adder. So all of these things should be stable because they're the stable output from the adder plus the input from this combined with, this is my input bits, combined with the current instruction that I'm trying to execute. So, in switching these things, they'll be unstable for a moment, but they shouldn't ever change the values coming out of the latch until its clock is triggered. Or a flip-flop. It's a flip-flop, whatever. Same deal. I want to make sure its clear pin is actually stable at 5 volts. And that is pin 1. .03 volts. All right. Tapping that chip was causing it to trigger its... I'm going to swap out the one chip. I'm going to swap out the flip-flop. That's what I'm going to do. Because any other weirdness can be explained in other ways. But that flip-flop is flipping me out. All right. The flip-flop is the 175. That's the 283. Flip-flop is, wait, 170. What? Oh yeah, 175. That's the 175. I actually have a chip puller somewhere, but I don't know where it is. Okay, that was a huge mistake. I should have found my chip puller. So when I did it wrong, I had power shorted straight through the clock pin. No, I did, well, when it was wrong, it was wrong. So let's try not shorting this pin out, this chip out. And then I'm going to have to stop after this, I think. Dog needs a walk. I have a meetup that I am running tonight. I mean, it's my own meetup, but all right, everyone, let's make sure we do this correctly. Hot is white. That goes to these input pins right here. Ground is black. It goes here. Everything is neatly wired up. I am going to put this in clear. That is clear. No inputs. Clear, clear. And I'm going to turn it on. And I'm going to trigger the clock. Nothing happens. Okay. Now I'm going to try doing the add A to B. Why did you do that? Now I have a million pins to straighten out on this. I'm going to disconnect this. I said I was going to stop after this. I have clearly debugging to do. All right, disconnecting that. I'm hooking the ground wire back up here. I'm going to, if I tie the clock to 5 volts, then it also should never trigger, right? Because it's only supposed to trigger the clock on the leading edge. Okay, something is not right. It's almost as if I have something else going to the clock line. I'm going to look at my schematics for a minute. The clock line is currently floating. All right, I'm tying clock straight to ground. All right, you and you. Clock is tied straight to ground. Shift right. Clear. No, hold. Clear. Clock is tied to ground. You're not supposed to do anything if your clock is tied to ground. Clock's tied to ground, but somehow we're still getting not even a flicker of power across that. Clock was ground. All right, well, thank you to everyone who gave to the ALS research during the stream, and sorry that I am ending you on a bug. It feels like the Doom stream all over again in that regard, but I have no idea. I must have miswired something somewhere. It's the only thing that makes sense. I'm gonna have to double check my wiring diagram. But thanks everyone. I'm going to go ahead and shut this down. Thanks again for the people who gave, and thanks for joining me for the stream. I will talk to you all later.